The following content has been provided by RWTH Aachen University.
Good morning, everybody. Welcome back to Designing Interactive Systems 1. Today we're going to talk about prototyping the non-computer kind, most of the time actually. Before we do that, we'll do a really quick review of what we talked about last time. So we introduced the DIS cycle, which consists of, what are those three letters standing for? Yeah?
Design, implement, analyze.
Design, implement, analyze, exactly. So it's an iterative process, and we go through those lots of times. There was also the double diamond model. Why were there two diamonds in this model? Anybody remember what those represented, those two diamonds? Yeah.
Because we have to broaden our ideas and data knowledge about the user, everything, ideation, and then we have to design, just narrowing down it to design a single.
That's right. So you sort of, that's one diamond, right? You narrow your understanding of the problem space and until you actually understand the problem. And then comes diamond 2 for the implementation, right? For the actual solving the problem, right? So that's an important part. You notice that a lot of these things are actually moving our focus away a bit from thinking about solutions and actually thinking about the problems a bit more, right? That's a general topic that you will find whenever you talk to a designer. You'll find that they reflect on what the problem actually is much more than we tend to do from an engineering standpoint. We usually assume that there is a given problem with parameters and then we go out and solve it and optimize something. But what that problem is something that design folks are actually trained in identifying. Okay, and then here I come, shaking you away at 3 a.m. in the morning. What are those first three questions you ask when you start a new interactive system design? Yes, the lady in the white sweater. Well, you should give me one of those three questions. Like, I know it's early in the morning. You better rack your brain, but this is what gets the juices flowing, right?
I should know, but I don't know.
That's okay. That's okay. Trying is good enough. So, okay.
Who are the users? What is the task?
User and task, yeah, and the context, exactly. Right. So, who are we designing for, actually? What the heck are they supposed to do with this system, right? And then the thing that's not quite so obvious, that's why also you were like hesitating for a moment, like where is that actually happening, right? That's not something that you think about as immediately as these other two things. All right. Then we introduced personas. Now those were an interesting construct. What's a persona? If you try to explain that to your friend, yeah.
Persona is like a bit fictitious, I guess, person.
Yes.
That you will create with like certain problems, frustrations, and a background. To help you basically define it, what the problem is and what kind of problems you should design for.
So it's a fictitious person, that's important, but still sort of usually built from real data that you collected, right? And I think that's what you want to add, right? You don't just make it up. You try to you do your user research, right? And you find out who your user base is, and then you synthesize that into a fictitious but realistic person, in order to have more than just this ideal user that always does the right thing and always happens to know exactly how to use your interface, right? Never has their hands full when they're using your UI, never carrying a shopping bag when they're supposed to use the system, with two hands. All those kinds of details will come out if you have a concrete person. Makes it less elastic. Right? There's the danger of this elastic user, right? That always adjusts and fits what you expect them to know or do at this very moment. Okay, then we went into, so this is mostly stuff on, this is the whole process, like the DIA cycle. Double diamond is really just a reflection on what's happening in these, in these iterations, if you want. And the first three questions, that's also about like, discovery, personas. You've you're beginning to build a better model of your user, right? Understanding that, and then we get into ideation phases to understand how to come up with ideas for solutions, right? So what are some techniques about brainstorming? Like if you had to give, your best friend 5 tips if they need to run a brainstorming session, what would you tell them? Yeah.
One tip would be quantity over quality. Just
Right.
as many ideas as possible.
Right. So lots of ideas. We don't care if they're good ideas, just lots of them, exactly. Anything else? Yeah.
I think it should only last like 5 minutes because it's really exhausting.
Yeah, it's pretty exhausting, and you shouldn't go on for too long. Now there may be a lull in like ideation, and then everybody can go back and maybe look at what has been written on the wall, right, and reflect and come up with more ideas. But usually you don't want to go for an hour, like, otherwise you're going to be flat on the floor. Other hints for brainstorming? Yeah, right. So deferring judgment, right? We will ultimately go back to those ideas and look at them, with a critical eye and think about, okay, is this actually doable with, the budget or the technology or the people or whatever. But for the moment, you don't think about that, because if somebody puts out an idea, they're kind of a little bit invested in it. It's kind of their baby. And then if you go like, oh, here's my big, club, and I'm going to just mash that idea because there's all these things that are wrong with it, then nobody else is going to come up with a good idea, right? So you let that go for a moment. Very hard for us Germans. And you just build on top of each other's ideas. And then, you save your reflection and critique for a later time. Okay. So that was the structuring. Oh yeah, structuring actually is another topic. Like, what's one good notation method that we talked about to structure the stuff that you have brainstormed? How does that work? Yeah. A concept map, exactly. So key topic in the middle. It's essentially, you computer scientists, it's a tree, right? So. Mostly, right? So you may have some cross-branching going on between different areas, but mostly it's a tree of your concept. And this sounds really easy, but sometimes it's actually not that easy to find the right sort of abstraction levels and the right sort of subgroupings of where you want to go with your idea. It's going to be different for every project. The last thing we looked at were storyboards. So again, you're supposed to explain to your best friend what the storyboard is in interface design. Like, what does it look like? What do you do with it? Yeah, this was towards the end of the class. Like, oxygen was low. Yeah, go ahead.
I'd say it's like a very simple comic describing, like showing what the product or app does.
Yeah, right.
Helps you.
Yeah, I think comic is a good approximation, right? So it's supposed to be mostly visual to give people a view of what could it be like to use that system that you're dreaming up. And then you usually have some captions underneath that explain what's going on, or some, thought bubbles of what's this person currently, what is their problem currently. You may remember Bob and his, augmented reality glasses, right? This recognition glasses as our example. And they serve to tell a story, right? To tell the story of using that interface. And the cool thing about this is you have to do no coding for this, right? You have to build no technical stuff to do all this. You can just, put your idea out there and get feedback from users really, really quickly and iteratively. So that's what, what really feeds the DIA cycle and makes it spin, right? That you can be fast in putting out ideas, getting feedback on them, putting out more ideas. This is a very typical work mode of this early sort of design phase. All right, so now let's assume we have an idea. We've done our storyboard on our idea. You did some last time in class on the things that we were coming up with on the spot there. And you've, maybe based on the feedback that your users gave you, you've got a few concepts that you think are promising, right, for your system, for your solution that you're looking at. So now you need to prototype this. And the first thing we're going to do is we're going to prototype it without actually involving a paper. So we're going to do paper prototypes. And that's actually a picture from a prototype that was done in I think, an earlier DIS class here in this very class. Paper prototypes are usually your first prototypes. Well, I guess that's a bit of a lie, because you could say that your first prototype is actually the storyboard if you want, right? And sometimes when I do like consulting for companies, or when we're involved in a UX project, the very, very first prototype I sometimes do is just literally a paragraph of text, where I'm saying, like, this is how I imagine the persona we've maybe come up with, how they would be using the interface. Sometimes we don't even go to the trouble of drawing an interface, because we don't even know yet whether it's going to be whatever, a mobile app or whatever. But we just write a paragraph of text and saying, like, this is how we imagine this to take place. And that is already, maybe you could say, your first prototype, right? Because it describes a user experience. And then you do a storyboard maybe, and then, so the paper prototype is sort of, you could say, your first or second prototype, or maybe third, depending on how you count it. But the idea is it's very early on, right? It's quick and it's cheap. Cheap not just because paper is cheap, but cheap because it's fast to create, so your time isn't being wasted on, launching Visual Studio and pulling in widgets and wiring them up with code and stuff like this. So typically, paper prototypes are rough sketches, and they're rough for a reason. You don't need an artist to do these. This is really important. Right? Don't be afraid of paper prototypes. They're not artwork, right? They are tools to communicate something. And in fact, if they look a little dodgy, and you just sketch them out there without too much trouble for straight lines and stuff, that's actually good, because it shows that it's ready to be tossed out, right? If people say, no, this is not how we want to work, right, with the system here you're designing for us. We want something else. We don't want to, we don't want a big website. We want, a small mobile app or something. Or we don't want this launch screen. We need these other things on the launch screen. They need to be able to say this to you without feeling that they're ruining a lot of work that you've put in. So actually making it look rough is a good thing. And you might also think, ooh, computer, right? It's so tempting to do this on the computer, and it will do all the straight lines and stuff, and you don't need to draw them yourself and embarrass yourself. Don't go that way. Actually, do it on pencil and paper material. It's much quicker, less of a threshold of passing it on to somebody. If you've got your sketch on your laptop or iPad or something, and it's like, yeah, okay, I'm going to send that file to you, and you can print it or look at it on your tablet and stuff. Don't go that way. Try to really stay with the analog medium for a start. It's not to say that you can't do a sketch on a digital drawing tool, but really good digital drawing tablets are actually pretty expensive and pretty rare. Most artists will tell you that it's actually hard to simulate the feel and the quality of paper drawing. So hand-drawn, no rulers. You don't need to make straight edges here, and try to really avoid using the computer for this. I'd rather go in and sketch on a piece of paper and then take a snapshot with my camera, with my smartphone, and send that on, rather than going digital from the very beginning. So, as I just said, the fact that it is rough and not with a lot of detail is actually an advantage, because it means that you as a designer focus on the key high-level UI design questions, and you don't go in and fuss about, ooh, is this button going to be square, or is it going to have rounded edges? We don't care at this point, right? We care about what's the very general navigational structure of this app. How does it very generally appear? What's the overall flow through this system that you might be designing? And not only you can have this focus with a paper prototype, but also the user, right? If they see this and they see a button that's just been scribbled there, then they know, okay, this could be a Windows button, it could be a Mac button, it could be green or blue or red. Whatever, it's a button, right? But it's already so abstract in their head that they're not going to fuss about what color it's going to be or how big it's going to be or what exactly is going to be the font that you use to write the text on it. They're more going to be worried about, this button says open, but I don't know what opening means in this context, because maybe it's a banking application and opening doesn't make sense to them. So they're going to get that more high-level abstract feedback from users as well. Now, of course, paper prototypes also have their challenges. First of all, the sequence of interaction, like what happens over time in your UI, is actually not that easy to convey in a paper prototype, because it's a stack of screens, if you want, right, that you draw. You may actually have to drive the paper prototype yourself. What do I mean by that? Well, I have like 10 pieces of paper, each with a screen. So I give them to you. You're my user. And I say, this is a start screen. What do you think? What does that mean? What would you do if you had to, I don't know, write a letter with this app or something? And you'd be like, maybe, oh, I guess I would tap on this new button here. So then I shuffle through my stack of papers, right? My sheets, and I find the right sheet that does that, like that looks like that next screen that you would see, and I give that to you. So I'm the sort of logic behind the paper prototype. I'm driving it, right? I'm advancing through the various stages. So you can't really easily give a paper prototype to a user and say, like, try this out and tell me later what you think, because they won't know how it works, right? There's no live connection between screens or telling them where to go from where. The other thing is, of course, especially if your paper prototype gets bigger, you've got lots of screens to draw. That's a lot of work, right? All the challenges of the analog medium, of course, will come back to haunt you, right? So if you're trying to do a paper prototype with hundreds of screens, then you're really going to wish you had a computer, right? Because, of course, a lot of this stuff is repetitive. But I'm going to show you a couple of tricks that you can do to stay in the paper medium, stay away from the computer, and actually make paper prototypes scale up better and make them more interactive and having to do less repetitive drawing. There's a couple tricks you can do. As I said, your storyboard could actually be your first paper prototype. And so the difference here is your storyboard is actually a couple screens next to each other, right? Like a comic, like we said. Whereas the paper prototype itself is more of like a screen at a time. So the paper prototype tends to be really more about the UI, where the storyboard is like, you're zooming out with the camera, right? If you're the director, you're actually trying to show the user in the picture, you're trying to show where they are, and then maybe in your comic storyboard, at some points you zoom into the UI to show what they're doing on the screen or whatever it is, but then you go back out and maybe there's other people they interact with or they do this task for or something. So you're trying to show a lot of the context in your storyboard, where your paper prototype is actually sort of, mostly the UI itself. There's sometimes cases where you show a bit of extra stuff in a paper prototype too. We'll see some examples of that later. For example, if you have an app that prints something, then your paper prototype could have maybe showing a printer to the side that's going off. Okay, so we're going to take a look at two kinds of paper prototypes. The first one is more like a storyboard. As I said, your storyboard, we know what a storyboard is, so now we take basically several sketches of the UI, several snapshots of the UI. Most user interfaces fall apart into individual screens or user interface states, right? VR games or stuff like this are a little bit of a different beast, right? There you have less of a discrete advancement through static screens, and you have more of a live environment. That's a little trickier to do with paper prototypes. But if it's your standard utility app or something, you've got these UI snapshots that you can easily identify. Then you label each of these with what's going on the screen, and you make sure that you also label connections. So basically, you say, like, if somebody clicks here, then they would end up on page 15, snapshot number 15 that you've sketched. Which means if if a user is really determined, they could actually sort of navigate your paper prototype by themselves, but it will be a lot of shuffling through stacks of paper. Here in the storyboard-like version, you could actually have several snapshots next to each other. So it looks more like a storyboard, and that makes it easier to go from A to B to C. Right? The problem with that is that what you mostly can show with this is essentially one sequence of interaction. So because if you're putting them into one order, right? So if I read it like a comic, then I'm going to go through one interaction sequence that takes me from like the welcome splash screen, whatever, to an opening file dialog or something, to working with the file, then maybe printing or saving, and then quitting the app or something. So you'll have this one sequence through there, right? Or maybe the sequence is like purchasing something on a shopping website you're designing, right? That will be one purchase ordering process from A to Z. So that's a little bit of a limitation where you're really only laying out one scenario in there. And as I said, the storyboard is a bit of a zoomed out view, showing lots of the environment, the task, the user, whereas the storyboard-like paper prototype of your UI shows mostly the UI. Right? It's more zoomed in, you could say. So the other version is what I was describing when I said, like, I'm handing you, or I have the stack of papers. It's more like a flipbook, right? So you have maybe each user interface snapshot goes onto a separate piece of paper, right? So you have these screens, you've got the stack of paper, and you can collect them in like a binder or something that flips over easily. And then you go through and say, here's the start screen, and now the user does something, and then you flip to the corresponding next page, you show that page. Or sometimes you will find that you actually keep these interface snapshots as separate sheets of paper, and you hand them to the user one by one. That's also a good option. Right? This allows you to simulate a user interface for the user. Right? So here's one example of a storyboard-like prototype. Again, this is from the picture from an earlier class. As you can see, somebody did something interesting here. They drew the storyboard, right? So the storyboard plays out this way, down here, and then it would come to this and this and this and so on. So you would read it like a comic. But they said this is going to run on, and this kind of shows how old this picture is, right? It runs on a mobile device that has an awesome keyboard with tiny little buttons on it. So they designed this little frame, right, to show that each of these is going to be appearing on a mobile device. So this is almost like your viewing lens to show where you are in your interaction. It's kind of cute. And oftentimes these simple props, right, these simple cardboard cutouts and stuff, really make a difference in getting people into the mode of imagining that they're actually using, let's say, a mobile app. Right? For us, for the designers, it's clear if we sketch a bunch of screens for a mobile app, it's going to be running on a smartphone. But for a user, this may not be so obvious. Right? So giving them these little bits of props, like in a play, makes it actually a little bit more realistic for them. And here's a picture of a Flipbook prototype, also done by DIS students, as you can see, in 2010. This is actually kind of cute. This is a Flipbook of, they were prototyping an application for the iPad. And the idea was that they were actually using a frame with this cardboard here again to allow users to hold the box. This was about some like medical, like a doctor's application where you could browse a patient's data. So they created this box so that the user could hold this thing while they're testing it in their hand, right? So basically, the scenario here was fixed. So basically, the idea was, you show the thing to the user, and then you pull out the front page, you give it back to the user. That's the next page they see, and so on and so on. So there was only one path through this. Yeah, go ahead.
When I'm designing like for an iPad, why don't I just draw on the iPad and then show like, I can just draw with a pencil on the iPad, right? Why would I draw it on paper and then create a cardboard iPad?
Yeah. I know this is very, very tempting, and absolutely, I invite you to, if you have something that is as good to sketch on by hand as a piece of paper, go for it. The danger of, I don't know if you've noticed this, but the danger of prototypes or sketches or drawings that appear on a computer display is that when you do them in a sort of in a loose hand fashion, sort of, you sketch stuff, it sometimes just looks a little bit, how should I say this, like, it looks a little bit low quality. Whereas if you do this on a medium that is actually, where it's natural to work that way, it looks a bit more authentic. It's hard to express this, but that's one reason. The other reason is if your user drops this cardboard prototype, you haven't lost anything. If they drop your iPad, it might be more expensive. So there are some things where, yes, this takes more work to create this cardboard cutout, but it really also communicates to the user, this is definitely not the final system. Right? There's another thing which we'll get to when we get to more advanced software prototypes that run on the computer, which, again, this is hard to imagine for us because we see through all the smoke and mirrors. But your average user, if you show them something on a computer, there is a tendency to think that this is the program, this is the app. I mean, yeah, if you sketched it by hand, the dangers of confusing that with a real system are pretty low. But as soon as you get a little more high fidelity, if you give them something that looks like the real thing, even if it's just a bunch of Keynote PowerPoint slides, they might think, oh, system is done, software is done. So that's another danger we're trying to avoid. So yeah, we're trying to have we're trying to communicate to the user this is a quick and dirty and rough prototype that didn't take a long time to create, so that they are ready to critique it, even with fundamental things, and that's why we try to stay low tech in this space. But yeah, I mean, if you feel more comfortable sketching on an iPad than on a piece of paper, I would still invite you to try paper for a while, to play with it and see the differences in how you can express yourself. But you could do that and then print out your sheets and put those into a cardboard stack too, right? That's another option. Fun fact here: this was done by a couple of students here, and one of them, Ignacio Avellino, and also Kashyap Todi, actually continued to do their PhD in human-computer interaction, and now are researchers in Aalto in Finland and at the University of Maryland in Baltimore. So big things happening once people took DIS1. Here's a bit of an overview of how that feels to use this prototype. So this would be your first screen, right? You get your patient overview, where you have some data about the patient, and then you got a couple of different options here, buttons to press. And this is sort of giving you an idea that, what kind of problems he has. This person has diarrhea, unfortunately. And now, if you actually click on history, and what I did there was like I showed a little bit of an animation of a finger pushing, right? That's only something I can do because this is not running on a computer. Otherwise, this will be what the user is actually doing using this paper prototype. You end up with this, history view of the timeline of the patient and all these tests. So you might say, like, okay, what happens if I touch the X-ray in the middle instead, right? So let's do that. And then we end up with the next page, where I get a detailed view of the X-ray image with additional information. And you may also have noticed right now already, here's the limitation, right? When I give this thing to the user, I actually have to tell them, look, I know there's lots of buttons there, but I would really, really like you to press this one because that's the only, that's the only sequence I've actually laid out in this prototype, right? So you need to sort of tell the user that they are going to be playing a fixed script, right? They are going along with a fixed interaction. That's one of the limitations of this linear prototype. We call it linear because there's only one path through the interaction. You can, of course, if you're driving it yourself, if you're not just pulling the top sheet off the stack, you can make it nonlinear. You can say, like, push any button you want. I've got them all sketched out here in my little stack, right? And I'll show you the corresponding one. Or in your Flipbook, you could flip to that page. But if it's something that the user basically drives themselves, or you're just basically taking the top sheet from the stack, then it's only a linear sequence through the interaction. So here's your detailed view of the actual image, and so on. So you can see how paper prototypes work, right? And we get an idea that it's running on a device of sort of tablet size, but we don't know whether it's a Windows or an Apple tablet, and what color the UI is, or how exactly things are being laid out. A lot of that is, is left to the imagination, and that's for good reasons. Yeah.
If we have planned just one scenario, just a couple of buttons working and completing the task, is it better to tell the user to test the whole task, for example, writing it for her, or just telling her in the beginning, or it's better to do it step by step?
Well, if that's a good question. Like, what do you tell the user in the beginning if they get something that is only a scenario in one way? Depends on why are you doing the test, right? And usually you're doing the test to see, A, if users can make sense of your UI, and B, if they can tell you whether that's actually supporting the task they're trying to do in a good way or not. So it makes sense to tell them, I'm going to give you, maybe it's an application here for doctors, right, to go through a patient's data. And you could tell them ahead of time, I'm going to show you an interface that lets you browse, patient data. But that's probably all I would do. And then I would show them the first screen and say, well, here, let's assume that you first want to look at their X-ray, right? And then you would let them hopefully pick the right button to press, right? If they tap somewhere else, nothing happens, right? It's a piece of paper, so you're good. You can just tell them. And then you would take them to the next screen. And then I would explain, I would actually let them explain to me what they think they're seeing. Right? That's a good way to get into this. This will be something we talk about later in evaluation. Actually, just asking people to explain an interface back to me is a great way to see what their mental model of the UI is. So you can see whether their picture of the interface is actually the same that you were trying to imprint on them, right? Yeah.
It looks like when we ask them to do it step by step, for example, what is working now,
Yeah.
for this screen, it's a bit confusing for them, but why isn't the case? So I was wondering, maybe we can just prepare the task that is working and then let them just go through it.
Yeah. So the limitation of this single scenario thing is clearly there, and you're not going to be able to get the same kind of feedback from a user as if you could actually let them go crazy with it, right? So if you have all the buttons sketched out on little sheets of paper, then of course you're really free to say, here's the start screen, what do you want to do? And they can do pretty much anything. We can't really do that here. I would probably still, well, based on what we learned about mental models, or memory capacity in the very early part of this class, you don't want to overload people with information, right? So we find that a good rule of thumb is when you give people instructions for a user study, you only give them the next step at any time. You don't give them all the 15 steps because they're like, whoa, that's a lot of stuff. So just the information as they need it is the best, because that's not, you don't want to train them to become users of the system. You want their feedback. All right, now, how are we doing on time? Okay, we got a little bit of time before we break. So post-it prototypes. Paper prototypes are lots of screens to draw, right? And how can we save some work? Well, we can save some work with good old post-its, right? Sticky notes. This is a version of a prototype that's a little bit more interactive already than a paper prototype. And what you do is you basically create your dialogues, your windows, your menus, all this kind of stuff on post-it notes of different sizes, not just one standard size. You actually cut them up into small pieces sometimes, in 2, 3, even more layers. This allows you to simulate changes of just part of the UI, right? So when a user opens a drop-down menu, you don't need to draw a complete new screen, which is really annoying to do. You just basically draw the drop-down menu and stick it on there, right? And covers the rest of the screen, just like a drop-down menu does in an actual application. You can simulate dialogues that open up, all this kind of stuff. And not only does that mean that you have less work to start with, because you don't need to draw all these full screens. You just draw your main screen once probably, and then a couple elements as they change and appear and disappear. But also, if during your test you discover that the user says, oh, I would really like to have an online help available at all times. You're like, hold on a second, scribble, scribble, scribble. Here's my question mark on a little sticky note. Imagine that's there like all the time. You can stick that on the screen right there. And then they can say, okay, so what if I press that? And you have to kind of draw the dialogue. So you can really go in and be quite flexible and responsive in your test session and sort of co-design the UI with user feedback. As I just described, let me just draw this little question mark, and that's quick to do. But then let me just draw this little help screen. That's probably a little bit more work, right? So it might make sense to have a couple templates ready. For example, a template for a dialog box that pops up, or an alert or something, right? And then you can just fill in what it says and stick that up there, because you will probably be working. If you're working with a standard user interface toolkit, then there are standard things like dialogues popping up or menus, and so you can draw these as empty widgets if you like, and then just fill in what they're supposed to say on the spot. This can often get quite interactive and maybe not go as you initially planned, right? Hopefully you discover some new things in your study. So it's a good idea to tape what's happening. Just have an overhead camera filming what's going on. Capturing the audio as well. Of course, you need consent from users, right? Always need that when you videotape users, that they're happy to do that, and you need to tell them what you're going to do with the video. Not post it on YouTube, but really just like for example, it's only going to get shared in the design team of this company or whatever. Yeah, go ahead.
Do you always need like a paper version of the consent for videotaping them, or is it enough they just say, yeah, it's fine.
No, you want it on paper, yeah. And in fact, when you run studies, typically, like for example, if you do this as a company, for example, you would always collect the paper, signed release form saying like, I agree that I'm being videotaped there, and that and then on the other end, it also says what's going to happen to the files and what's not going to happen to the files. So yeah, doing that in writing is a good idea, just to cover your behinds, let's put it that way. But there's usually standard forms for doing this. Yeah, okay, so a couple examples here, right? This is best seen rather than being told. So here's an example of radio buttons and checkboxes, right? You can see here, so here's, for example, this is some kind of configuration dialog, like we don't care what it is, but here's a way to select something from a drop-down. Here's a height adjustment that you can do here with up and down buttons. And then there's, here's a check mark, for example, right? And so check marks are easy, right? You basically just draw the check mark on the background of your dialog, and then if somebody taps that, you just put a little, checkbox with a check mark inside it onto that, right? Let me run a video, actually. Maybe this is even better to explain how this works. We have a short example on how that is being used. You can see like somebody going in, and these all are glued on as post-its. So you can see you can move or replace them. You can change the height to be some other. You can have different numbers labeled on there. All of these are easily removed. See, even the radio button can move up and down your list if you want, and you only need to draw one of these. This is a way in which the user can tap and then say, okay, I want to tap this, and then you, in response, sort of move things up there. Now, there's whole books on paper prototyping. It's an art form, right, in itself. There's lots of good tricks to make this easier and more convenient for you. I'll show you another example here. Let's say somebody, you need to design a dialog box that has this like expand the details kind of thing, right? How are we going to do this? Well, it's easy enough, right? If somebody taps on the details, you basically just literally unfold sort of, your piece of paper, and you have maybe the details scribbled on a piece that you had folded behind the original, right? That's an option to do this. Or let's say you have these expandable lists, right? These are also kind of, you're like, oh, how am I going to do this in a paper prototype? Well, it's not that hard, actually, if you think about how they work. You can go in and say, well, if, let's say somebody wants to see what's inside the music folder, right? And they tap on it, you could just put a sticky on top of that and show what's inside there. And then, yeah, your games thing is now gone, but you could also have that as an extra piece to be attached beneath that so that the lines are continuing. It's not perfect, but it's good enough to give people a sense of how they navigate through, right? Next up, we often have grayed out controls, right? For example, if it doesn't make sense to select a particular menu item, then we gray it out so that it's not available, right? So what do you do to do that? Well, here's an example, right? We just literally stick over the normal one. We stick a little post-it that has the same word in grayed out font, right? That's an easy approach to do that. I'm not saying that save and print, disabling these is the only way to do this, but it's an example of how to handle these kinds of user interface situations. Here's another one, also taken from DIS students, that was simulating a touchscreen UI with a paper prototype. The idea here was that this was a user interface for a copy machine that would allow the user to manipulate what the copies should look like, right? So like how the image is being cropped, that is being photocopied. And they actually used, as you can see here, separate pieces of cardboard to simulate the crop marks, and users can move these crop marks during the prototype test back and forth, right? That's the idea here with these little crops. Okay, so that's paper prototypes and post-it prototypes. Now, remember, we are going through the DIA cycle, so you do a design, you implement it. Implementation may mean that you draw a storyboard, for example. You test with users. You go back to your design phase. You think about what you learned from the user study. You put that into your design, and you create a new design, right? And that next design might be a post-it prototype, for example. You go back to the users, right? And you test with them, and you see, am I still on the right track? Am I still shooting for the right thing here? And then you go back with your feedback to your drawing board if you want, and then you do the next kind of prototype. And as you go through that's already 2 iterations, right, of the DIA cycle. As you go through this, you are gradually adding more and more fidelity to your prototype and making it more like a real system. Let's continue with the next kind of prototypes, all right? So this is software prototypes. Software prototypes are medium fidelity prototypes, so we're moving the detail, the precision, and the interactivity up a notch. But I would really urge you to not start building these until you've done some paper prototyping. Again, I know we're computer scientists. We like coding, right? We like to build stuff and build stuff on the computer. But stick with the piece of paper and pencil kind of stuff, and maybe go out to Listmann here in the city, buy yourself a really nice, A3 drawing block with like art paper and stuff like that. Or get that for Christmas from your parents. Get some really good like Sharpie or edding or something like markers in different sizes, and also thicker line widths, not just your tiny little ball pen width, but go bold on these. Get yourself some really nice pencils of different hardness and softness, and maybe some colored stuff too, right? Some colored Sharpies or whatever the equivalent in German pen style is, and try out the sketching. It can actually be fun, and it's going to be much more enjoyable if you don't do it with your crummy old ball pen on your college square-lined paper, right? That's sort of, it's kind of lame. Go be an artist, at least in terms of your equipment. You don't have to be an artist for yourself, but get the equivalent equipment and enjoy doing this. You'll find that it's actually a lot of fun doing that. Practice those starmen and hands and stuff. By the way, I totally forgot last time to show you how to draw faces. So make sure to go back to that video that I showed you, that I linked to see how you can draw faces that look at other people and stuff like this. We have a little bit of an instruction there in the video too. Anyway, so after you've done your paper prototyping and you're ready to build something using a computer, this is still not a software prototype the way that you might think where you're coding stuff, but it's something where you're now allowed to turn your computer back on. We're going to be mocking up some aspects of the final UI. So usually not all of it, right? Still, I'm going to talk about that in a second, how you limit prototypes. It's going to be on the next slide, but we're not building the whole user interface in a prototype, not all of it. We just try to explore some aspects. A simple example of these things is using PowerPoint, right? To show essentially, a presentation of slides that are screenshots of, stepping through. And in the very simplest case, it's just a linear progression, just like what you had on paper, but a little bit more high fidelity. It looks a little bit more like an actual application. Remember that what we're doing here is not about the functionality, right? So if your app is about, geez, I hate coming back to this, but online banking, right? You don't need to talk to a banking server at this point, right? You just make stuff up, right? Like with the Max Mustermann, patient data, you're not linking to some, real patient data. You don't need a database in the back end. You just put stuff onto screens and hardwire everything just to create the impression that the system is working. So the advantage of software prototypes can be, depending on how you build them, that they're actually something that users can play with by themselves a little bit more easily. They also tend to be easier to share. So if you want to give it to a whole bunch of people, if you only have a paper prototype drawn on a sheet of paper, yeah, you could photocopy it, right, and hand it out to everybody. But at some point, the digital version then becomes easier to share with people, of course. And also to use when there's no designer around, because as we will see, you can put some logic of your interface into your prototype even at this stage, even if you're just using something like PowerPoint. Now, I said that we limit prototypes, and there's two fundamental ways in which you can do that. The first approach is what we call the horizontal prototype. Why horizontal? Well, imagine a layer model, right? You all know the ISO, OSI, 7 layers, right? So anyway, at the top, you've got your user interface, right? And below that is your functionality. So a horizontal prototype means we only implement sort of, the top layer. We don't actually build the underlying functionality, the database code, the algorithms, the logic to make it work. We just simulate everything, right? That's meaning a horizontal limitation, right? And that's pretty clear how that works, right? You simulate all the interactions. Nothing actually works in this prototype, right? It's just fake. But you do see the entire UI. The other way to limit things is the vertical prototype, where you say, I really want to see how people use this, this app for real, but I'm not going to build all the saving and printing and whatnot. I'm just going to make a very specific subset of the functionality available. Maybe it's a drawing app, and all it can do is draw a circle. There's no saving, no loading, no printing. It can only draw circles, right? That could be a limitation that you decide to do. And then you actually do implement down into your code base. You do build the code to draw a circle, but you build nothing else. There's no drawing rectangles, there's no lines, there's nothing else. Right? This allows you to test a more general idea that you might have by example. Remember I showed you a screen in the history section on the very first spreadsheet app, right? VisiCalc. So imagine you're the person who invented VisiCalc, right? Nobody had ever seen a spreadsheet app in their life. They didn't know what that meant, right? This didn't exist. So there's this person sitting there, and he's like, scratching his head, like, okay, so how am I going to test my idea? So he might go ahead and implement something and say, I'm going to make this grid of numbers, but all you can do in there is, enter numbers and have them add up at the end or something, right? And then let's see whether people find that useful. Nothing else works, right? There's nothing else you can do. So that would be a way to test your idea with a more vertical approach. In reality, you may often mix the two, right? You may say, I'm going to just, create a user interface where lots of the stuff is not interactive. It's just sketched out so that it's there, but it doesn't actually react to anything. And then I have a few things that do actually react, and maybe I need to implement a bit of code. In most cases, you don't actually have to at this point. Yeah?
Oh, sorry, I didn't get that. Is it just about functionality that for vertical there is something working? And
Right. So the idea is, imagine the whole blue box is your whole program, right? At the bottom is, built in the lower levels is your low-level code that, your business logic, right, that you write, your model classes, if you think about model view controller. And at the top is your user interface, right, that drives sort of the things that are being used. So one idea is to just make a user interface, but have no code to actually trigger things. And then when you say, I'm showing you patient data X, then you just display a screen that has hard-coded in some images and text of some patient rather than having an actual database down here. Right? The other limitation is, this is your entire app, and you say, I'm not going to do saving, I'm not going to do printing with the UI and the code beneath it, I'm not going to do database access, but I am going to do, I don't know, maybe rotating the 3D image of the X-ray. Right? Maybe that's something you want to show. And then you have the user interface to do X-ray rotation, and you have the code that actually does that, but nothing else really works. Yeah.
but the parts related to the other stuff,
Yeah.
empty or the UI elements are
Yeah. Good point. What you end up often doing is then the rest of it you might actually only implement as non-functional, just for context, so that people know, oh, the app will have all these things available, but the only thing I can try right now is rotating that X-ray image, right? And another, so it might look more like this, like combined, right? So a thin horizontal plus a vertical one, and sometimes you decide to actually only do this little square here, which means you are combining, you're not making the entire user interface available, and you're also not implementing anything. You're only giving a small part of it, which would be more like the scenario driving, basically saying, I'm only going to give you one way through the interface, so all the rest of the UI isn't even accessible, and of course there's also no code to back it up. So this is actually may be misleading. This is, in a way, this is two pictures in one, right? This could be your vertical prototype implemented plus a thin horizontal layer of the rest of the UI for context. But it could also mean, if you just basically built this little thing here, that you only have a fixed interaction path through the interface. Let's look at a couple examples. I think this makes it easier to see. So if you have the simplest prototype that you can do with software is basically just like what you did on paper, right? So it's a screenshot prototype. You can use Photoshop to put screenshots in, and you can have layers of multiple images to step through, for example, or you can use PowerPoint, have a sequence of slides in there. So what you do is basically you draw your screens essentially one by one. You may even use your digital medium to show several screens on one page, like with a storyboard prototype, right, if you want to. And so this is a very thin horizontal prototype, right? It already makes it easier to change things than with hand drawings, of course, right? So if in this function somebody says, I want an online help button like on every screen, that's easy to do, right? To just cut and paste it on all your digital slides rather than having to, draw lots of these little things. And it allows for a bit more visual detail and visual quality, right? So where your paper prototype was really, a black and white pencil and marker sketch, you're now moving to something that could maybe use color, use maybe a bit clearer font and stuff like this. Depending on how high you turn up the quality setting here, the software screenshot prototype, the artwork that you put in there could actually become part of the final UI. I've had this happen. We did a screenshot prototype, which I'll show you later, on an interactive conducting system, and the artist that we had on the team just drew screens that were so beautiful that we basically took the artwork and it literally became the artwork that we used in the final product. Doesn't have to be like that, but it's possible, right? Screenshot prototypes are also useful if you have to do non-standard GUIs, right? Because especially if you are imagining, I'll show you the picture of this conducting system, but that's a good example. It didn't have any standard, menus or something like this. It looked like an art installation. There was no user interface toolkit to draw from, so we had to basically, draw them from scratch or have them drawn from scratch by somebody who knew what they were doing. And so this is an example where it helps to have user interfaces as a screenshot prototype, because you can do non-standard GUIs. Also, of course, easy to distribute electronically. Let's look at a couple examples. The first example is actually an example of this is sort of kind of like an in-store shopping app. You know how these days at Rewe you can go in and scan your stuff as you're purchasing. Imagine something like that being thought of years ago. So this is what you're seeing here. You're in like a toy store or something like that, and you have this interface. Right? So this UI is basically saying, okay, find the item you want in the catalog, because there's supposed to be like an in-store catalog that you're running around with, and scan the barcode next to that item. So you've maybe you found this thing, this stroller here in the catalog, and so you scan this, like this is your brochure you brought into the store. So here's how the prototype simulates this. This animation will show you how the barcode gets scanned. See, there's a little hand with a scanner coming in, and beep, it's scanning the barcode, goes away again, and once that happens, we've now added the stroller to our shopping basket. So now, as you can see here, we can pick this color, right? Right now we've picked it as a green stroller, but maybe we want a blue one. So we'll go in and instead tap on blue, and when we tap there, the cross moves from green to blue. And now we can place the order, right? So we go in, tap on place your order, and when we do that, what happens is, this is what I meant by sometimes you add a little bit of context to your screenshot. The printer will, spit out some kind of order sheet. And the idea of this app was that, you now take this printout to the counter at the front, and then they will make sure that the stuff gets, from the warehouse gets brought out, and you can put in your car or something. So what you can see is, don't worry too much about the shopping app itself, but you could see, like, with just a couple of screens, I could give you a feel for what this app might want to do, right? So this was a very simple app that didn't need much in terms of graphic design. In this case, we were actually using fairly standard components here, probably even just screenshotted standard buttons with some text on it. Some of the problems of plain screenshot prototypes is that we don't really have interaction, right? What I just did was a scenario, right? I just sailed through one interaction. There was no alternative. I couldn't click on anything else. I literally just advanced next slide, next slide, next slide, right? So it really works more for like pitching a story, right? Pitching a particular user interface story. The other danger is coming back to what you asked about, like why can't I just use my, draw it on the iPad? At this point now, if you show this to somebody, like upper management, they might say, well, this is awesome, sir or madam so-and-so. It looks like we're almost done. I'm going to go and announce to the shareholders that our software is shipping next week because obviously it's all there. Right? So people without the technical understanding, go back again, what we talked about in DIS earlier. To the user, the interface is the system. Right? That's actually a fairly common conception. Right? And so when the interface, this illusion that we're creating, us magicians, if users perceive that to be the whole system, when they do see an interface, even if there's no system beneath it, if the system walks the walk and talks the talk and looks kind of like it's working, they will assume that the system is there. Right? So they don't understand necessarily that it's just stepping through a series of screenshots. So that's the danger that upper management might misunderstand you. The other danger is if it looks really polished, like what you just saw, you may limit your users in the kind of feedback that they give you, because they might say, oh, that looks like you've done an awful lot of work there, so I'm not going to criticize the fundamental layout of this thing here. I'm not going to ask for it to work completely differently. But you could maybe change the color of that button or maybe change that text to something else. Right? So the feedback that you get with a more polished prototype is going to also have a tendency to be more on the details, right, and not on the big things, because most people will be hesitant to criticize things in a fundamental way if it looks like there's a lot of work that went into it, right? And that's what a polished prototype looks like. It looks like a lot of work went into it. Finally, of course, we're missing sort of the physical aspect of devices, obviously, but that's going to be a problem that we have to face until we get to hardware prototypes later. So we can add a couple of things, right? So we can add some effects to screenshot prototypes to make them more interesting. We can have scripted simulations, right? For example, what you just saw with the hand moving in and out, that was already a little bit of an animation running. I didn't have to do anything, just advance to the next slide. So you can make that happen. That's interesting and makes it more lively. You can use media tools like PowerPoint or Photoshop layers to create things that are a little bit more interesting, right? And so you can transition from one scene to the next by simple input, or you can do this with the timing and an animation, as we saw in this example. In all, what you're creating is a prototype with slightly more vertical depth. You could say you are beginning to simulate the reaction to user input, right? It's not just a blank piece of pixels or a blank piece of paper anymore. It does react to user input, but it still doesn't drive any underlying code base, right? So we can use it as a click-through prototype. As you just saw, I pitched to you an interface for shopping, right? And that worked well enough, right? Everybody got an idea of how it works. But I had to be there, and I had to say and talk about what's going on. It didn't quite work just by itself. So it can look fairly real. Good for non-standard user interfaces. There's no programming needed. At this point, the disadvantages, we're currently still at a linear walkthrough to, so when the script that you're imagining isn't what people want to do, then they can't really use this prototype. An alternative is, and I'm going to show you this with this conducting prototype here, is to not have a sequential interaction script, but instead use something like, for example, Photoshop and its layer functionality to actually simulate things like highlighting different menu options or moving to different screens. Photoshop layers can actually do this with quite some panache. And when you see the screenshot prototype, don't worry, this is the one that I talked about, where we actually ended up using the artwork for our final product. Usually your screenshot prototype will look much less polished, right? Because you usually don't have the artist design the final artwork for it already. So here's a video, a 90-second video, showing you a walkthrough of somebody using Photoshop. We just screen captured this, using Photoshop and its layer functionality to step through the various effects in this user interface. So here we are in Photoshop, and you can see we've got we're opening up the layer view just so that you can see what's there. Right? There's tons of little layers that the artist actually created. And so what we can do now is we can turn on the foreground, and this is typically what you would see as a starting point. What's being enabled now, these 1, 2, 3, 4, 5 pieces to select from. And now we're highlighting all of them. This would not be a state you would normally see in the interface, just to show you that each of these layers is basically responsible for making one of these options glow, right, as if it had been selected. So an actual selection would look more like what we're doing here now. Turn on one and say, oh, if you want to see the next one, then you would turn off one and turn on the other. Also, layer comps, which is a composition of multiple layers, makes this a little easier. Here you can see we now only need to do one click in Photoshop down here to move the highlight on this selection screen here from one option to the next. Right? So this almost feels like I can actually, if the user says, oh, I want to highlight the Anna polka with my pointer, then you would basically just click on that section on the side here in the layers, and it would give you that look. So that's good enough to simulate a fairly non-standard interface at high visual quality. So how you would imagine using this is, you've got somebody showing this maybe on a laptop or something to somebody else who then says, oh, what if I press this? And then the person driving the interface would go in and quickly change to the next layer, maybe using a 2-screen setup to make it a little bit more believable, and simulate the interaction that way. Still this is not something that a user would want to drive themselves because they probably don't know how to use Photoshop, but you could use that as a tool. I'll show you another one, giving you an insight into the deepest and darkest secrets of the computer science department, because at some point we had to redesign the computer science department website, and I was tasked with that glorious task. So I decided to create a screenshot prototype of the website. And what I did here was basically I created a non-linear software prototype in Keynote, which is Apple's version of PowerPoint, and it gives actually a little bit more horizontal and vertical depth, right? Because everything can be made interactive, and clicking on buttons actually does something. Now, simulating a website is pretty easy because it mostly displays content in response to clicking on buttons, right? So there's not much going on beneath that. But the beauty is that I don't need to define a sequence of events any longer, right? I don't have just one walkthrough through this thing. I can actually let users do with this prototype whatever they would like to do. Right? So the way this was done, and this is showing you what was happening inside Keynote, was I took, for example, a button like here, the field Studium Studies, turned it into a hyperlink and said, oh, if somebody clicks on that, please link to slide 32. Right? So that jumps to a different slide. So let's take a look at this. Here's the overall view of this thing. And now if you, for example, click on, let's say, Studium here at the left, then what happens is literally that this thing pops out and opens up as a submenu. But you can also then move over to, from current topics like Aktuelles to, do you want to study here? Like, studieren bei uns, right? So then that's what happens. And all this stuff is moving through different slides in the slide deck, right? You can keep on going through all these different options here. Each of these is literally a different slide appearing. And there's other options. For example, here we can see, if we now go to Forschung, the research section here, then we're showing what we were imagining this interface to look like. And again, you can go to corporate relations, Wirtschaft, show what we were imagining there, and about the department, right? That was also available. So the nice thing about this was I was able to actually share this with all my colleagues, and they were all able to click through this and try it out and play with it without me having to write a single line of code. And I didn't have to futz around with a web development or anything like that. It was literally just building a little bit of a more advanced presentation in Keynote. As you may notice here, I did use the real logo of the university, but apart from that, I literally, consciously chose a sketched, like handwritten font. Right? I wanted to bring down the visual quality. I didn't want it to have, perfect lines and stuff, because I didn't want people to start focusing on these things too much. I wanted them to think about the topics, how the information was structured. I wanted them to take an abstract view of what was going on, rather than caring about the details too much. So that's one trick that, again, when you use your iPad to build interfaces or your computer, a lot of tools actually offer sort of a hand-drawn look to the sketch, and that's sometimes a good way to take down the visual glitz, just a notch, so that it looks a bit more like a quick prototype. So we've seen Apple, Keynote, PowerPoint, Photoshop, but there's actually, next to these, there's also dedicated apps for prototyping interfaces. Some of these are things like Figma, Balsamic, maybe something that a lot of people have heard about. Origami was one that was done by Facebook, now Meta. And Adobe XD is what Adobe offers as part of its gigantic creative suite. But you can even use something like Miro, right? Just as a brainstorming whiteboarding app, that works too. So whatever floats your boat, really. It's worth, however, understanding a little bit about what each of these tools can do well and what they're not so great at. So if you want to know more about this, we actually have a whole lecture on these kinds of digital tools, where we focus especially on things like Figma, Origami, XD, Balsamic, these dedicated user interface prototyping tools in DIS2. That's going to be in the summer. If you just can't wait for it, then maybe you can find the video online and watch it there. I want to talk a bit about what some of these tools let you do, right? So if you take the whole class of animation apps, for example, right? There's lots of different animation tools available. And they often use a timeline metaphor, right? So they basically work. This is what people do, literal animations with. So these work along a timeline metaphor. And if you have to do a very intricate animation that needs to be just right to show to your client for your user interface design, you can do that with these tools. They can be pretty powerful when you add scripts to them. They're not the greatest programming languages, so probably not what you want to use in your final product, but good enough oftentimes. And it lets you often integrate non-standard hardware and other operating system features into your prototype. So Adobe Animate is one of those examples of these tools, and this image is taken from the tutorial video that Adobe provides for its Animate tool. Again, more about this in DIS2. Sometimes you may find yourself actually being able to use the animation app for the final product. I remember I once, long time ago, I visited Apple, and as we were walking around, they were just getting things like the early Mac OS X user interface design ready, and somebody showed me a prototype of the dock. Right? The dock in Mac OS X has, or Mac OS these days, has this lots of icons next to each other. And maybe you've seen this, there's a mode that you can enable where each of these icons zooms in and magnifies as you zoom over it. So it looks like a wave going through where whatever you're pointing at gets bigger. It's a terrible idea from a Fitts law point of view, because you're always going to misjudge the distance to an icon you want to click on, but it kind of looks fancy. And somebody had actually built a complete version of this in, I guess it must have been, I don't know, Director at this time, like Macromedia Director, which is kind of like Adobe Animate, was an animation tool, right? So there was no line of code written. He'd written this, built this entire fluid visualization, magnification thing in a graphics app. But it showed you exactly how that effect would look, right? So sometimes this is the right tool to use, and If you're a visual designer, then these tools are second nature to you, and you're going to be very, very fast to create your interfaces with this. Another approach that, of course, offers itself. I mean, you've seen my keynote simulation of this web page, right? At this point, I could also have gone in and just used the web, right? It wouldn't have been too hard. So if you go and use HTML and JavaScript, that's a natural choice. If what you're designing is a website, right? Then you can, of course, also go in and just use these things. This is where you are moving more towards actually writing, if you want to call it code, HTML and JavaScript. And of course, the big advantage of that is that there's tons of tools out there to do this. You have a clear text format, so nothing is hidden inside an ugly sort of unreadable binary container. You can view it in any browser, theoretically, and you can share it over the net, right? But the precise look and feel, just the nature of the web, of course, is not what you can communicate. So if you want to be pixel perfect, web tools won't cut it for you. But of course, if your final product is supposed to be a website, this is a very typical approach. Just in case you're not aware, Electron is a package that lets you take a whole, basically a website, and package it up into a native application that you can then ship to run on Windows and Mac desktops. Things like the Atom editor, for example, or even Slack are Electron apps. So you're basically running a glorified browser when you launch these things, and it makes them huge to download, but it's a nice way to use basically web technologies and put them into a local app. Cappuccino is also a framework that lets you create advanced web apps. The other approach, and as you can see, we're slowly moving more and more towards your comfort zone, the IDEs, right? Is using rapid development environments, right? There's visualbasic.net, or maybe you've heard of TickleTK. It's a pretty old scripting language and GUI toolkit. These are great if what you're creating is a standard GUI app, right? That uses the standard toolkit from wherever you are. So, for example, if you're supposed to build an application for inventory tracking, right? It's probably going to use mostly standard user interface parts, right? You're going to use standard menus, buttons, dialogues, etc. And so you don't need to, once you've done your paper prototyping and stuff like this, and your maybe a screenshot prototype, you don't need to go in and recreate all those things. You can use something like Visual Basic to create that, right? Visual Studio gives you often options to do these kinds of things. You may run into performance issues if it's an interpreted system, but that's something that you're aware of. On the other hand, development cycles are pretty quick if you work with these tools. Distribution might be a little bit tricky because a lot of these tools are not cross-platform, and they may require a specific runtime environment. Apart from these rapid development environments, and I would say at this point probably you could almost put Swift UI, Apple's Swift UI Xcode, alternative to designing user interfaces for mobile apps, or writing whole mobile apps actually, into that same basket, right? It's a couple lines of code and you've got a UI. If you don't want to build a standard interface like that uses typical Office software user interface components, then you may still find a special purpose prototyping tool that works. I'll show you one example. Has anybody here heard of Max MSP? Anybody ever? No? Okay. Max MSP is a tool that was originally designed in the 80s to write MIDI applications. Anybody heard of MIDI? Ah, okay, a couple of musicians in the house. Oh, good. So MIDI is basically a protocol that was created to send notes between synthesizers, right? So it would tell a synthesizer to play the following note with the following sound. Not wave files, but actually sort of these control messages. Soon enough, some geek figured out that you could send and receive these MIDI messages also from and to a computer, and of course, all the crazy computer music folks went bonkers and built weird interactive music installations using that. And MaxMSP originally started out to support this kind of work, right? So you would build an application like what we see here is basically a couple boxes that each have inputs and outputs, and data would flow along these lines between these boxes and get then basically its input from, for example, a MIDI controller that's connected and would send its output to the screen or to the speakers of the computer, or maybe out to the MIDI port to send to some other sound or lighting equipment, something like this. So the metaphor here is what's called flow-based programming, right? So you are connecting things with these lines, and data flows along these lines. It's a very interesting, very different programming metaphor that I really encourage you to play with for a bit. It makes some things super easy, like reacting to incoming events, even multiple incoming different events in parallel. Super easy to do, right? You just write a couple of these patches, each reacting to different kinds of input. They all run in parallel. The runtime takes care of it. You don't have to worry about multi-threading and blah, blah, blah. On the other hand, writing loops, for example, is kind of hard with these things because loops are a typical imperative construct that's hard to do in flow-based programming. But if you need to write an application that reacts to incoming sensor data or audio signals or something like this, or gesture input, and needs to respond to that in kind, this is a great environment. I ended up building my first interactive exhibit in like the 90s with MaxMSP, and I initially just used it for prototyping, but we found it worked so well that actually we shipped the final product with it, and it got installed in a museum and ran there for a couple of years. So there's a free version available. It's called PD that you can play with. If you want to learn more about this, though, there's also more information in DIS2. Final part is probably interface builders, user interface builders, and these are tools, graphical or textual tools that define user interfaces of some real software application. So usually, these things are part of an integrated development environment. A couple advantages using these is that when you build stuff with an actual user interface builder, like Visual Studio Code, or Visual Studio, sorry, or Xcode, then you are creating something that looks exactly like the real thing because it is the real thing, right? You're using the actual user interface components, the actual buttons and scroll bars and whatnots, of the system that you're ultimately going to be releasing. Oftentimes, you can actually reuse what you built in your actual code, right? So you're basically creating things that can be assets that directly work to become your final product. And of course, it's also easy to add vertical functionality because, hey, it's a development environment, right? So it's the environment that you are going to be using to actually code the whole thing in. The limitation is that you're typically limited to the Windows system and toolkit that it supports, right? So if you're building something for in a typical Windows environment, then you're writing it for Windows computers, right? You're going to have a hard time bringing that over to other platforms like Linux or the Mac. Things are getting better in that way, but it's still mostly one platform. I actually thought I'd show you one example of this here, just as a sneak preview. This is an example of using Xcode on macOS to build an application, a Mac application that converts temperatures. You may remember temperature conversion from the classes on counting the information content in interfaces. So what this does is it gives you the UI, right? And you can actually assemble your user interface here. You can bring in components from a library and, for example, add just text fields and buttons, etc., to your user interface. You just drag them in, like in a graphics tool, if you want. But what's neat is that you can also specify the transitions between screens, right? So the way that this works in Xcode, at least with this kind of development that's happening here in AppKit, you are literally defining the transition, from one screen to the next in these kinds of connections. So you have a storyboard, and it's actually called storyboard in Xcode. You can see there's the main.storyboard that defines how your screens are connected together. This gives you a nice visual overview of what's going on. Plus, and that's probably the biggest strength that you get when you use these kinds of environments for prototyping your UI, you can, if you want to, wire your code indirectly, and modern IDEs let you do that by literally dragging and dropping, right? So here we are literally dragging and dropping from the convert button to a piece of code, and we're connecting these two together, meaning I want this action to be called, this function to be called if the button gets clicked. That's how this is done today. Back in the days, you had to go through lots of hoops to wire your code and your UI together. Nowadays, this is much easier. There's more about that in DIS2 as well. As you can see, this moves into the technical questions of how you build user interfaces, and that's what we cover in DIS2. But I should say that actually something we just very recently covered in iOS, our class on iPhone and programming, etc., is the SwiftUI method of building applications, which is yet different. There you would only have one kind of code for both your user interface and your actual application. And the application is, the user interface is being built by the code that you're writing as you write it, with a very nice live preview function. So that's probably, I would say, if today I had to quickly prototype an interface that used the actual toolkit for like macOS or iOS or on an iPhone or iPad or even on a watch, I would probably use that, because there you can literally write a couple lines of code and you already have a basic interface up. So I encourage you taking a look at SwiftUI, or maybe peek into that recording of our iOS class on the topic if you're interested. Now, software prototypes have a couple issues too, right? The first issue is that users tend to focus on design details and overlook larger problems. I already talked about this, that it can look fairly polished, and that it distracts from the big questions. You might not get the right feedback from users. They might be afraid to criticize things that you've done or suggest changes to your design because it looks so nice already. Management may think that it's real. I explained that misconception earlier on, because the user thinks that the interface is essentially the system. So when that happens, then you really need to sort of maybe give people a peek behind the scenes and show them, no, look, this is actually just a PowerPoint presentation or something like this. So let's get to the last part here of hardware prototyping. I mentioned earlier on that most of the prototyping that you've seen so far kind of leaves out one big aspect, right? And that is what is actually the physical experience of working with that user interface that you're designing. We saw a couple of hacks to get a little bit more physical, right? For example, the frame pushed over the screens, or the frame that you put the screens inside already gave me something to hold on to. And what we're passing through the rows right now is the prototype you're seeing here on this interface of like a simple remote, right? So the thing with hardware prototypes is that you need to do them whenever a system that you're designing cannot be just defined by software, right? So if you have something that really requires users to experience the physicality of holding a device or reaching out to it, working with it, then you need to consider building a hardware prototype. And hardware prototypes are almost, you could say, almost orthogonal to what you're doing in your software prototyping or in your paper prototyping, because in your software paper prototyping, you're basically most often fleshing out what the pixels are about that you're displaying, right? Most of these plays or most of the interfaces we design end up being mostly visual. And so all the prototyping you've seen so far was essentially about that visual aspect of the UI. And independent of that, you can go ahead and work on hardware prototypes that capture how the device will feel. Now, if you're doing a mobile app for a smartphone, then you don't need to invent the device, right? It already exists. You can just use one of those cardboard cutouts and say, that's the size of a smartphone, and here's my screens inside it, and we're done, right? But if you are part of a design team that is creating, let's say, a remote for a new device, and the physical size and shape of that device is also up for design and not already predetermined, like with a mobile app, then that's a good idea to also have, it's a good idea to also have a hardware prototyping going on and linking those two together. And linking them together isn't always easy, right? I mean, we saw examples where you slide some paper designs of your interface into the physical cardboard prototype, like the thing that's being passed around. I think that has actually slots, right, where you can, you have slots on the side where you can push in the screens. So that's one way of doing it. But if you want to get interactive and you're now building, let's say, a screenshot prototype with some nonlinear functionality, with some active buttons, how am I going to get that onto the hardware, right? That's a bit of a challenge. And is one of the reasons why we created the Fab Lab at our chair, actually. The Fab Lab at our chair is a workshop where you can 3D print and laser cut things and program some electronics and build some little embedded displays with microcontrollers and stuff like this, all because this gives us the tools to actually prototype functional hardware prototypes, not just mock-ups like made from cardboard. So you can see how the software prototypes, or the visual prototypes, let's call them, went from pen and paper to linear screenshots to nonlinear simulations, all the way to the IDEs, right? But the hardware prototypes were mostly, if you do one at all, you're usually mostly stuck at the cardboard level, right? You can do one from cardboard or foam core or one of those materials or wood, but then making it do more than just being this dumb piece of material is really hard. And so to fill that gap is actually where you can benefit from knowing how to program an Arduino to show a little bit of content on a screen, for example, if you're prototyping a device, or how to read a couple buttons, light up a couple LEDs, those kinds of things mean that you can actually put simple functionality into a hardware prototype. So I want to tell you another story that I thought was really fascinating. Has anybody here heard of the Palm Pilot? Palm Pilot. Yeah, okay. Remember what it was? Can you?
I think I heard about it in a video about before the iPhone, where smartphones existed.
Yeah.
So I'm guessing it was, if I'm remembering it right, it was a pre-iPhone smartphone.
Yeah, it wasn't actually a smartphone. It didn't have a functionality to call anybody. But what it was essentially, people called these the PDAs, personal digital assistants. So it was a little bit piece of, about the size of, I don't know, about the size of an iPhone, very roughly speaking, but only with functionality to like store your contacts, open up your calendar, scribble notes and stuff like this. And it used a pencil for a digital pen for handwritten input. Actually, it was built using the handwriting that the folks at Xerox PARC developed, the Unistroke handwriting, where you have to do all the letters with just one stroke, and so they are easy to recognize by the computer. So it was something that was designed in somewhere around the 90s, and was supposed to be carried around with you as your digital, diary, calendar, contacts, address, notebook, those kinds of things. So smartphones didn't exist and wouldn't exist for like another 10 years or so. And the guy who ran the company that was making the Palm Pilot, as it was called, did a curious experiment. he said to his design team, guys, before we start discussing what kind of features we put onto this device and how it's going to work technically and all that, I want you all to carry around these wooden blocks with you for like a couple of weeks. And these wooden blocks were literally like just wooden blocks of different sizes, thickness, height, width. And people were asked to carry these around all day long during a typical work day so that they would always have them with you. Because he said, no matter what we put on the Palm Pilot later on in terms of digital, whiz-bang and features, if people don't find the device comfortable enough to have with them all day, it's pointless. Because what good is a calendar if you don't have it on you, right? If it's lying back on your office desk because you didn't take it with you because it was so cumbersome to carry or something. So the design started, at least one aspect of the design started with people walking around with these wooden blocks in like their shirt pockets or their trouser pockets or wherever, handbags, in order to figure out what's the right size, thickness, width, etc. What's the right shape to actually create a device that people feel comfortable carrying around. And I don't have a picture here, but feel free to Google Palm Pilot, look at the final device and what it looked like. It's actually a curious little bit of a wedge shape that gets a little thinner towards the end, so it's really comfortable to put in and out of the pocket. And it was, roughly the size of a modern smartphone, I would say. So what that shows is that, and the Palm Pilot was actually quite a success in its time, right? It was one of the most successful modern, sort of, back in the day, personal digital assistants. Definitely beat all the others that were out there that didn't have that convenience of fitting into a pocket nicely. So physical interaction can be important, right? So when you have this Palm Pilot was something that was not easy to imagine if I didn't know what kind of size of device I'm even talking about. So for that, it made sense to have that block design. When physical interaction becomes important, that is the case when you're designing a new device where people can't really imagine it without that. So here's the example of the 3D mouse. If you're designing a new 3D mouse, how are you going to make software prototype of that? It doesn't make sense to click through a screenshot prototype of a 3D mouse, right? I need to hold this thing and understand how it feels and how it moves and how big it is and how sensitive and how precise, et cetera, et cetera. So, and even if I don't have all the electronics and the logic worked out yet, I at least need to get an understanding for its physical grip so that I know what it's like. When you do create hardware prototypes, you can use wood. Wood is a surprisingly, malleable and easy to work with material, as you probably all know from school. Foam core is another thing that, like, architects just love foam core. Foam core is like this squishy material between two sheets of slick white cardboard, usually, like lacquered or high glossy cardboard. And so you can cut it to size and make things that have nice surfaces but are still sort of very rigid and robust, not like making it from a single sheet of cardboard. So foam core is a great material. Maybe you know what that's called in German? I actually don't know. No. Anyway, you can get it, in Aachen you can get it easily because we have got an architecture department. So, plastics of various kinds also work well. Styrofoam, although styrofoam is hell when it starts. Never try to cut styrofoam with anything else than a hot wire. That's the only way to cut styrofoam without making your life a misery, because otherwise you've got these tiny little statically loaded pellets everywhere. And of course, cardboard as a fallback always works too. And lots of these things we can actually cut, like wood and certain kinds of woods and cardboard. We can actually cut on the laser cutter that we have in our lab. And I would say at this point today, you probably add 3D printing to that, because when you design in plastic, that means you don't necessarily need to carve it by hand. You can actually design it on a computer and have it 3D printed. The problem, of course, with these things is when you create a hardware prototype, it's actually it's quite an effort. It's more effort than sketching out a screenshot or even creating a Keynote file. and changing it, right? When you decide, oh, that wood block should have been bigger. Yeah, you're probably going to be making a new wood block. Yeah.
Would virtual reality be somewhere in between software and hardware prototypes? Because I think, you cannot really touch something, but at least you have like the feeling of like moving, or for example, if you think about like factory designs or something, you can like have some feeling of distance to objects.
Yeah, that's a really good point. I haven't thought about how that slots in here or to add it to the slides. But you're right. With what you can create with virtuality is sort of mostly a visual impression of an object. And that makes a lot of sense for lots of products. I don't think it replaces, it can replace the hardware prototype, right? I don't think that was what you were saying. But you can, and that's being done, definitely, you can have sort of an early version of your hardware prototype being created with much less effort and easier to change in VR to just look at, and then at some point you might say, well, now I need to 3D print it or cut it or whatever, and actually make it so that people can take it in their hand and play with it. Yeah, that's definitely an option. VR, or also, I would probably even say that AR there makes even more sense if you get the scale right, because then you can place the thing into its real environment, right? If I'm designing something like the Palm Pilot and I can put it on a table next to my real objects on my desk, then I can see its actual size and how it relates to everything else. Gives me a bit more context than being in virtual reality. Yeah. I love this picture. Microsoft at some point developed what they call the touch mouse. And the touch mouse had some additional sensors that were touch sensitive on the top. So you couldn't just click the buttons, but they were also touch surfaces. What the team did was that they carved dozens of, like there's a whole box of these things. They carved dozens of these possible variations in what's called Renboard. Renboard is a kind of soft, low-density foam that is really easy to sculpt with. The team, there's an article on Wired about this in 2011, if you want to look that up. But what the team said is that they found that they couldn't compute the perfect curve for a mouse. You had to sculpt it, you had to hold it in your hand, play with it, try a bunch of variations, and only then you could actually say whether it fits perfectly or not. So that's a good example, I think, of showing how intense hardware prototyping can get. Of course, this is not something that a bunch of computer scientists did as a side project, right? This is professional industrial designers going about their work and being part of a large team creating a new product. This is also a picture I really like. Anybody heard of the Pebble watch? Yeah? Remember what that was?
Sort of like a Fitbit.
Yeah, it was sort of like a Fitbit. It was an early smartwatch that actually had surprisingly long battery life because it used one of those e-ink displays, right? So it would run much longer than everything else that was available at the time. It was pre-Apple Watch. But the Pebble watch, I actually had one at one point, was quite convenient to wear. It wasn't that thick because it didn't need this cute clunky battery, and the display was quite nice. And this is also a 3D printed prototype of the Pebble watch that was being created by the team as they were trying it out, right? Again, I think for a watch it's super important to see what exactly is the size, how does this feel on my wrist, like will that still fit over, will my clothes still fit over it or not, and so on. And that's something we can totally do in our Fab Lab up there with the 3D printers and stuff that we have around. So if you end up doing projects with us at the lab in some capacity, you'll be able to play with all those wonderful fabrication toys. Once Corona is over, by the way, just as a hint, we're also going to have Open Lab Tuesdays, where Tuesday afternoons you can come over and pre-register for an hour time slot, and then print whatever you like on our 3D printers, even if it's minis for your favorite board game. So it's a way to get to know digital fabrication technologies by playing with the tools. So Corona could just maybe stop now, and then we can all go back to that. This one is the one that we were passing around, and it shows, I think, an interesting combination, right? You've got this cardboardy foam core material. The buttons are actually, I think, made from this foam core stuff and glued on top of this, where you have a slide in here on the side to put in screens, right? So it's a good way to show how to design hardware prototypes. And the last thing I want to share here for hardware prototyping is this video. One of the first labs I was running when I was here in Aachen, you can tell by like the ancient style of Apple displays we had back then, right? Was a lab where I asked people to design musical instruments. And this is Laszlo Bardos, who was one of the a member of one of the teams, and he designed what he called the virtual air guitar simulator. I think it was actually called Bangorama. So the idea was he had this guitar that he made from, as you can see, cardboard and stuff like this, right? He put a couple touch pads on there, which was just aluminum foil, that's conductive. He wired those up to an Arduino and had it talk back to the computer via a cable. And so you were able to use your left hand to decide which fretboard you want to touch, a bit like, you know, Guitar Hero or something like this. But how do you strum the guitar, right? That's the question. Now, strumming the guitar, he said, well, in the style of music he enjoys, people are headbanging all the time. So what he built was this thing there on top of his head, a tiny little switch made from a piece of copper and a 1 cent euro coin, 1 cent coin. And that 1 cent coin would always tilt against this rest of the copper wire when you banged your head with this hat on. And that would basically trigger a little signal that was also being captured by the computer via the Arduino and would play the next note. And I know you want to see the video for this, so I'm going to show you. So as you can see, also using Max MSP to quickly prototype this. So this is the kind of stuff you can actually build. And that's what I was talking about with functional prototypes in hardware and software. I think this is, you know, the days of just designing user interfaces as pixels on screen are long gone, right? Today we're designing always for, yes, maybe pixels on a screen, but they're always in some kind of device. Or maybe it's something completely different like this. And there's tools out there that let you explore both the visual prototype with all the paper, screenshot, etc. prototyping tools, Figma, Balsamic, etc. But there's also more and more tools out there that let you explore the hardware side. And I know we computer scientists are always a little bit nervous when it comes to hardware, right? You know, it's not our original realm maybe, but it has become much more accessible recently. So be ready to play with some electronics, some Arduino, some sensors, some actuators, and you can actually create user experiences that are very unusual, very non-standard, and that open up new ways of using computers, which is something that I enjoy terribly. It's what I mostly do in my work. I got one more technique for you, and then we're really going to wrap this up. So this is Wizard of Oz. Wizard of Oz. Okay, who has seen The Wizard of Oz? Ah, okay, quite a few people. All right, so what's so special about the wizard in Wizard of Oz? Can anybody tell me? Towards the end, kind of, yeah, go ahead.
System is imitated by a real person, and
yeah.
Sometimes it's about, for example, evaluate. I don't know the
evaluating. Yeah.
No, the system when you go up and down with.
Oh, elevator.
Elevator, thank you. And then the elevator talks to the person who are in the elevator, but this is not the elevator. It says it's instead a person who is talking to find out how the user will interact with the talking elevator.
Yes. So just in case you're getting nervous, none of that happened in the movie. That's that's okay. What you just described is actually an example of using Wizard of Oz prototyping. We'll get back to that, but I first need to finish the story with the movie. So in the movie, the wizard in Wizard of Oz is actually, it seems like this gigantic person, right? And in the end, he's just this poor guy behind a screen pulling ropes that make this big figurine move, right? Remember that maybe if you've seen the video? So the Wizard of Oz is basically a fake, and that's what the prototyping technique is about. And now back to your story. So let's imagine we're in like an age where we want to design a smart elevator that reacts to voice commands and talks back to you, but we don't have the voice recognition and all that working yet, right? Maybe it's in 1984 or something. IBM was in a similar situation when they were trying to design a voice recognition text editor. Same story. But let's stick with the elevator. I like that. So how do you test out a potential user interface design for a voice-controlled elevator when you don't have the voice recognition working yet? Like your voice recognition team is frantically working away, probably all graduates from Professor Nye, right? And is working on the voice recognition. Meanwhile, you are wondering like, okay, so how's the interaction actually going to feel? And are people actually going to want this, or are they going to be freaked out by it? So what you do is you put people in the elevator, you put a speaker and a microphone into the elevator, and you wire that up, wirelessly or whatever, to somebody who is behind the scenes, right? He's sitting outside. The user doesn't know that they are there, usually. And so the user gets into the elevator, you say, this is a voice-controlled elevator. Please, try it out to get to, I don't know, like the 4th floor. And then they will go in and say, like, 4th floor, please. And then the elevator, which is actually the person behind the scenes, the Wizard of Oz, basically, right, says 4th floor, going up, something like this. And so then the user will be like, okay, that was great. Or maybe, when they speak not so clearly, maybe then the human wizard can fake like not understanding what's going on. So what's happening is that this human wizard is driving the UI. He's simulating what the interface would be doing, right? That's the idea of Wizard of Oz technology. So you use this when you don't have the technology to actually do what the system is supposed to be doing available yet. But you need it to simulate the UI, right? You can't do a screenshot prototype of a smart elevator, right? Doesn't make sense. The danger of this is that you have to know as a human how to simulate the system. Because if, back to your elevator example, if the person who's like faking the elevator just answers anything that comes to their mind, then they will have a normal conversation and they will be like, oh yeah, I'll take you to the 4th floor, no problem. By the way, how are you doing today? And how was your morning? And that's not realistic for the system that was being designed. So the user, the wizard who is driving the interface has to work with a script that tells them how the interface would react, how the interface is supposed to react if it hears certain things, in this case, the elevator. And so the example I just explained was where you hide the wizard. You don't tell the user about the wizard. This is also what IBM did with their voice recognition editor. They had one person basically sitting in front of, this is like the user, right? So the user is basically, speaking into a microphone and thinks that they're talking to a smart voice recognition editor, when what's actually happening is like behind a screen, the wizard, and this would not be as close as it is shown here, just as a diagram, the wizard would actually be typing in whatever the user was dictating, so that it would seem as if the editor would actually understand the voice. You can also reveal to the user that the wizard exists. That's also okay. Sometimes that's impossible to avoid, and it changes the dynamics a bit, but it's also a possible way of running Wizard of Oz studies. We actually did Wizard of Oz studies in our lab quite a few times. So one time, for example, we were developing a system that would basically place virtual audio sources into a space. Right? Imagine you walk into a space, you put on headphones, and it sounds as if there is an audio source, and you can turn your head towards it, and it moves towards your center, and you walk towards it, it gets closer, all that kind of stuff. So we were working on a system that would do that. This requires precision indoor location tracking, right? Well, we didn't have the location tracking working yet, but we wanted to know how users would react to it anyway. So what we did is we put people into one of our rooms up there, the media space, and we had them walk around with headphones on, and somebody was in the room looking at where they were going and was carefully adjusting the volume and panning of the audio source to match, their position. So without actually having head tracking and orientation tracking and indoor position tracking available yet, we were faking it by somebody who was basically adjusting the audio to sound as if it knew where you were going, right? So that's one example of Wizard of Oz. Or we had another example in 2010. We had a study by Tong-Yang Ning, who was doing his thesis at our lab, who used 3 cameras to record users interacting with a big screen using a gesture-based interface. And she told users that the cameras were for actual gesture recognition, when what was actually going on was that she was looking at the camera, seeing the gestures, and then doing the corresponding reaction on the big screen. Right? So she was being the Wizard of Oz in this situation. So don't forget about Wizard of Oz. It's just one slide here, but it's actually a pretty important prototyping technique that can get you out of a pickle when you don't have the tech available, or maybe it's too expensive to set up, but you still want to see how the user interface reacts. Just fake it. We really have to get used to this. As computer scientists and engineers and developers, we're always used to, well, it has to actually work, right? Otherwise, it's no good. When you just want to know the user reaction, all you need is a believable illusion, right? Because the interface is an illusion anyway. So if we can create that illusion without having to spend lots of effort in implementing and so on, we're actually saving time for the project and effort for the project. Okay, so let's assume we have a prototype, and this is, we need to decide one last thing. What do we do with it when we're done? And remember, I think I said this before, right? A prototype is always a question, right? So all the prototypes you build are there to ask questions from users, from the rest of the design team, to work out how your interface is going and whether you are designing the right thing. So let's assume you've done your user study with your prototype. Now what, right? You've got this wonderful cardboard, thing there. Yeah, you can give it to me and I can show it around to future classes of DIS students. That's one option. But inside a project, what you will typically do is you will hold on to it, at least for archival purposes, so you can explain later on how your design developed this way. But you could also toss it out, especially if your prototype in general was designed quickly and cheaply, like you made a paper prototype of your interface, and you've learned everything from it that is there to be learned, you've documented it with photos, you can toss it out, that's fine. Right? If you, and now it gets a little more tricky, you build a software prototype, maybe even in, I don't know, I would say Swift UI now because I'm a Mac person, but maybe in, I don't know, Visual Basic or something, you build one, or in Director or animation tools or whatever. And you've tested it with users and you've learned everything from it that you wanted to learn, you may throw that away too. Throw away in the sense that you're not going to continue using those digital assets in your rest of the project, right? You don't need to literally delete it, of course. But there's also an option that your prototype may actually continue its life. One way to do that is to say, well, I've built a software prototype now, and I've learned something in my user test with it. I'm going to implement those changes in that prototype and test again to see whether I'm on the right track, right? So then you stick around with the prototype, and the prototype improves and gets a little bit more powerful. This can go as far as the prototype becoming the final project, sorry, the final product. That's exactly what happened to me in '97 when I designed this WorldBeat exhibit, where we continued working with Max MSP, this flow-based programming for music input and stuff, and it just went so well and was so well suited to the task that we just ended up shipping that, right, installing that in the museum. The problem with those things when you stick with your prototype technology is, of course, it has to, in the end, be production strength technology, right? It has to work, it has to be maintainable, it has to perform under high loads, or whatever the realistic settings are. So that's something you need to check for. But it's an option. So think about these issues, because if you spend a lot of effort in an advanced interactive prototype, and then you do everything again from scratch in your development environment, you are throwing away quite a bit of work, right? And if you can get your assets over from the prototyping stage and your assets actually work in the final implementation too, that's saving you quite a bit of hassle. Modern tools like Figma or Adobe XD actually often have these workflows, right? So they say the graphic designer can go bonkers here on the graphical user interface and design their hearts out, and all the assets they are creating, the digital assets they're creating, can actually then be thrown into a development process where you're building the actual code and you just use the imagery and animations maybe even from your prototyping stage. Okay, so let's wrap up for today. What I think became clear is that you need to do lots of iterations of prototypes, right? You're not done with one prototype. We've seen that paper prototypes are for high level, and high level, I don't mean high level of sophistication, but I mean high level of looking at the big problems, right? The major issues, the major questions of your user interface design. So for rough UI design, where you ask the high level questions, like is it an app, is it a website, is it a, I don't know, a smart wall display or whatever. We've seen storyboard-like prototypes that look like a storyboard, but are actually more like zoomed in screenshots of, like in a comic style. And we've seen the Flipbook, where you go through page after page of your interface. Then we've improved interactivity with poster prototypes. So we said we can be a little better and have less to draw and less to throw away each time, so that we can stick little post-it notes onto our interface. And software prototypes were the next step, right? So that you maybe create just a straight scenario or a non-interactive, non-linear sequence through your interface. You can limit prototypes in a vertical way, saying I'm going to just implement parts of it. You can limit them in a horizontal way, saying I'm just going to ignore implementation and just build the whole UI. And there are combinations of the two approaches too. The tools we've seen are things like animation apps, the web tools that are available, interface builders, also wireframing apps. We haven't talked about these much, but those are typically tools that people use for website design, where they really just lay out these box designs that I showed in my computer science department website example. I didn't create that with using a wireframe app, I just used Keynote, but wireframing apps are dedicated for that purpose. Well, and finally, if the physical interaction is important, and it is becoming more and more important for more and more products today, because of IT just making it into everything that surrounds us, hardware prototyping is a great approach. Finally, the Wizard of Oz technique lets you simulate behavior or complex vertical functionality by just replacing it with a human that knows how to provide the right answers. Right? Even if you say, oh, this thing needs to respond with a complex query in a database, if you don't have, instead of implementing the search algorithm that does all the complex queries, if it's too complicated, you don't know yet how that's going to work, let a human just type in the response. That's fine too. And we can throw away each prototype, or we can keep it around to work with it in another round. Yes?
I have a question about prototyping with the DIA cycle.
Yeah.
Where every iteration of the cycle, what is like how much should you add to the prototype? Because if you add too much, obviously it's hard to get feedback on everything, but if you had too little, they're probably not. The customer's probably wondering what you're doing and it's not really working. So
Yeah.
what is like the good estimate for?
Well, we're just doing a project for a museum up in Hamburg that want a guide app for their sort of outdoor space, and I noticed that actually for the first iterations we did, we had just sketched out some, like we were working with a graphic artist, right? So she created some possible screenshots of the app, using some of the design language from the museum to make them feel a bit more at home, sort of with the design, and that was totally enough, right? It was all just on paper, and we were able to debug a lot about the process of how we would imagine users, visitors that come to the museum to actually go through and use the app and find the things that they want with the app. And now that we've done that part, we're now going into building a software prototype, actually building the actual app, because it's so easy in with mobile app development toolkits to just create the full-blown application. But for example, we had limited ourselves to just focus on a few buildings. We made almost, I think we only had one thing that was really fully sort of fleshed out as an interaction. So the paper prototype was still a single scenario, just going through one step of things what you would do, whereas the actual digital prototype now has maybe half of the actual points that are interesting in the museum sort of implemented, as at least you can click on them and they come back with some filler text or something. So I don't have a good answer to how much you need to add. I think it depends on what kind of clarity you achieve in the discussion with your client, right? With the user representative. If you feel, yep, we're on the right track, we've sort of nailed where we need to go, and people are on board with the overall interaction, then you throw in the next, shovel of functionality and detail. But I think going in from in a form of a top-down approach makes a lot of sense, to fill in the big spots first, and also fill in sort of the stuff that happens in the beginning of the interaction first. Because if you start fleshing out stuff that people only understand after they've onboarded with the app, then it's hard to evaluate. Right? You need sort of the initial experience needs to be pretty clear, and that's going to be a lot of talking about before you get to the details. And oftentimes, I mean, the users are learning with you, right? So when you show them the next feedback, they've already seen the earlier one, so they know where we're going. And so there has to be a little bit of care that you're basically spoiling your users for you, right? So occasionally you need to test with a fresh round of people that haven't seen the design process yet, because otherwise they have too much prior knowledge and are not representative of a typical first-time user, especially in a place like a museum, right? Where how often are you going to use a museum app? Like once in your life, right? For maybe 2 hours. Right? So it's like it's the king's discipline of interface design. Like one-time users, no prior training. They don't have to use it if they don't want to. It's actually pretty challenging. All right, good question. With that, we're going to wrap up for today. Thanks, everybody, and see you again soon.
This content was provided by RWTH Aachen University.